Hey everybody. So OpenAI released Strawberry yesterday, or I guess the day before, technically. And yeah, taking first blush, it looks pretty impressive in terms of how it will probably perform on benchmarks and evals. However, from a technical perspective, having been in this space for a long time and having fine-tuned a lot of models myself, I'm pretty sure I know how they did it, and so I got the band back together. If you've been watching my channel for a while, you know that I've done, well, going all the way back, I started with prompt engineering and fine tuning tutorials on GPT-3, but then we did a cognitive architecture. That was the ACE framework team, and so today we're going to have a blast from the past, and I'm just going to fudge through a coding experiment the way that I used to. Today, we're just going to cover one part of this project. So, the getting the band back together, I've got a small open source team, and we're going to see if we can't make a model do reasoning at the level of, or obviously, we probably can't compete with OpenAI. They have literally billions in funding, which is kind of interesting because some people say, oh, you need to achieve SOTA benchmarks. It's like, that's kind of unreasonable to expect, but if a small open source team can get in the neighborhood of a enterprise, then great. So let me tell you. So this is kind of where we're aiming for. What I would personally like to do is to beat like Claude 3.5 at reasoning on Philip's Simple Bench over at AI Explained. Because if it can only get 27%, if we can get to 30%, that's going to be above what current models can do. Which, since we're going to be training on current models, that's kind of like a starting point. So we're going to get as high as we can on Simple Bench. At least that's the goal. So let me tell you how we're going to approach it, so that way you understand. Because this is going to be a series of videos. I'm not going to get it all done today. It's going to take probably a few weeks to get through. So number one is it's all going to be synthetic data to start with. This is how everything has worked with basically one generation after the other. So if you watch some of my other videos talking about basically the Strawberry live stream, or my video yesterday or the day before, whenever you're watching this, about kind of how Strawberry works. So when we started with GPTs, like the first GPT that I had access to was GPT-2. They're basically a glorified autocomplete engine. And when I say an autocomplete engine, I mean like you have to really give it like a few examples of the pattern of text that you want it to see. So it's really just a pattern recognition engine, which is why when people like, I don't know, some people get really weirded out about this because, like, honestly, if you think that this technology is spooky or scary, just go back to the original and you recognize that it's just pattern recognition. That's all that it's doing. Now, the patterns that it learns to recognize after you fine-tune it, it makes it more useful. So the vanilla unaligned models or untrained models, GPT-2, GPT-3, GPT-4, they're just autocomplete engines. So then what you have to do is you have to fine-tune it to get a specific behavior. The first generation of fine-tuned models that OpenAI released, excuse me, I don't know why I'm hoarse, were the instruct aligned series. So instruct aligned was able to basically follow a single instruction without giving it a bunch of examples to follow. Then so basically the vanilla models were able to bootstrap the instruct models with a combination of user data and synthetic data. And then we were able to create chatbots, which I've showed before, so I don't feel like I need to show it again. But and if you want to go back in my YouTube history, like just search like David Shapiro chatbot or whatever. Made plenty of chatbots. So you can bootstrap chatbots with instruct models. And so that's what happened with the launch of ChatGPT. So a bunch of us were training chatbots, with GPT-3 in the months leading up to 3.5 and ChatGPT. And so now chatbots with the ability to iterate through things, and I'll show you an example of that behavior in just a second so that you know what we're trying to reproduce. So basically, vanilla bootstrapped instruct, which bootstrapped chatbots, which then bootstrapped reasoning. So let me show you an example. Actually, here, reasoning. So there's a couple things that I need to show you. So number one, OpenAI shows you how they did this. They show you basically the kind of data that we need to generate. So here they give you a prompt, like here's a problem, and then okay, so it's like here's a cipher code. Use the example to decode this, and then they say like, okay, show the chain of thought. So it's thinking through the problem, and yada yada yada, and then so on and so forth. And so then if we expand it, oh, sorry, I had that backwards. What I first showed you was the solution. So here's what it's actually thinking. And by the way, Noam Brown at OpenAI confirmed that it's just trained to think to think through in a single shot. It's not a multi-agent system. It's literally just one model that has been trained to talk through the problem. So you've got one stream of consciousness, so to speak, or one train of thought, and it's talking through it as it goes. Which is like, okay, well, that's very straightforward. And we see that it's just using simple logic. And if you watch Philip's video on AI Explained, like it's not actually reasoning from first principles, at least the way that he said it. And I would tend to agree with his assessment. Basically, what it's doing is it's just seen enough of these problems so that it knows how to reason through a problem. So basically, it has practiced at reasoning enough that reasoning has been like reasoning through with a stream of consciousness has been embedded into its model. Now, I wrote this on Twitter, and it caused a lot of people a lot of heartburn. But like this is chain of thought reasoning that has just been cleaned up and put into the model. So here's an example. Let's see, analytical reasoning challenge. Was this the one? This was a challenge that someone gave me. So I found a prompt that you can use to get Claude to generate some of this data. So first you have to prime it. So model priming is something that I've been doing for a long time. And basically you engage in what's called latent space activation, what I call latent space activation. There's a few people that still get heartburn over that term. They say that's not what it's doing, but then they don't offer a counter alternative. You're queuing up the model with keywords. And so with latent space activation or this keyword priming, I just say, I'm going to give you a tough problem. You're going to need to use chain of thought reasoning here or system 2 thinking in text form to solve it. Do you understand what I mean here? Yes, I understand. So then I just gave it this problem that someone on Twitter gave me, and it got it. And the guy said that it got it right in the first try. So I was like, cool. I don't know how to calculate stock prices. So with the right prompting, Claude can already do some of these basic things, and it just popped out an artifact and said, okay, cool, here's how to calculate the problem. So the fact that Claude already knows how to calculate some of these things means that we can use this to synthesize data around problem solving. Now, let me see if I can find the other one that I did. Here we go. So this is the first one. And this was actually the one that I did that convinced me that this is actually a viable path. That we can actually use a chatbot to synthesize enough data as long as you've got enough problems that you can then synthesize enough data to bootstrap a reasoner. That's what we're going to try and do. So I'm going to give you a tough problem, et cetera, et cetera, et cetera. And it gave me pretty much an exactly identical output. So this is kind of setting the stage for the conversation. I said, excellent. Your output are limited to about 3,000 words on average, so you got some room to work. I said, write a 10-word coherent sentence where each word has exactly one letter more than its previous word, starting with the first word having one letter and so on until the 10th word having 10 letters. So just by telling Claude, use chain of thought reasoning and system 2 thinking, it basically behaved identically to what OpenAI said that they went through great lengths to train their model to do. So there's a couple possible ways to interpret this. One possibility is that Anthropic has actually been working on the same thing, which, to be fair, the original chain of thought paper came out over 2.5 years ago. So it did, and also Anthropic was founded about 2 years ago. So, like, I mean, it's possible that they're built on the same like technology and same theory. One of the points that I wanted to prove here or demonstrate, I don't know if it's proved, but that I can provide some evidence for, is that OpenAI is not really doing the research. They're just integrating research into a commercial product, which there is economic value in that. So when I criticize OpenAI, I'm basically saying, look, they're just making the sausage that someone else figured out how to make. Okay, so anyways, so we see that we can provoke the correct behavior from Anthropic, from Claude. But it didn't get it right in the first shot. Final verification, it said, I too the only child always craving attention from everybody. That's not a coherent sentence, and it doesn't even follow the rules. So then I said, not quite, but close. That's all the feedback I gave it. So what we need here is a verifier. So if I can give it a problem, and with just a little bit of encouragement, Claude can fix itself. I apologize for the mistake. You're right that it wasn't quite correct. It goes through and tries again. And it catches itself a couple times. So you see here, it's saying, okay, I didn't do this quite right. Let's try a different method. And then, so it came to A2, the 4 5s, always happily creating wonderful situations. And then I just gave it a little nudge. I said, almost coherent. This is tough. And it said, reaffirm the structure. So here we go. In this case, you can see it's actually reminding itself what to do properly. And brainstorm more words focusing on common versatile options, so it came up with a method. Now, when people say that LLMs can't plan, this has baffled me for like literally years at this point. I have seen since GPT-2, when correctly used, they have the ability to plan. So anyways, despite failing twice, it then just said, I am the most adept person quickly becoming unusually perceptive. And it tested its work. There we go. So what I'm going to do is I'm going to copy this out. And this is where we're actually going to begin the work. So what we need to do then is I need to figure out how to fine-tune this in order to actually train it. So typically what I would do in the past is like walk you through the whole process, but that might actually be a little bit boring. I'm going to clean up this data a little bit, and then we'll be right back, and I'll show you what I did to serve as this is a sample of what we want to do. So give me a second. I'll be right back. For you, the time that'll pass will be instant. All right, I'm back, and I've cleaned up the first sample. So to give you an idea of the kind of data that we're going to need, we basically will need to obfuscate a lot of this. So everything up to here, we're basically going to need to remove so that in the future, Claude will, all that it'll need, it won't need any system prompting or anything like that. Because this is one thing that a few people were impressed by. They're like, oh, it didn't need any system instructions, which I don't know that they don't have system instructions, but we can bake in system instructions into Claude, or not into Claude, into the data set. I apologize. So basically, we need to start here. Write a 10-word coherent sentence where each word has exactly one blah, 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 blah. So basically, we can obfuscate everything up to here where we give it instructions about how to behave and what it's trying to do. So then what we want to capture is first the user input here, and then we want to capture the process. But there's a few things that we're going to need to do to clean up this data. First, we're going to need to verify that it got the correct solution. So let's come back over to Claude. And what I'm doing is I'm showing you manually how I would approach this. Can you verify that this process was correct? Basically, we are grading training data, and I need to verify if you are capable of automatically checking the sample quality. And I'm not going to give it any other context. I'm going to let Claude read through this sample and tell me what it thinks. So, oh, look. Let's go through the solution step by step. All right, coherence. The sentence is indeed coherent. Oh, and by the way, there's lots of science out there over on Archive. Let's see if we can find some that basically says that like LLMs can grade each other. Or actually, let's use Perplexity. Can you search Archive for scientific papers determining if LLMs can grade each other each other's output quality using stuff like rubrics and such. All right, so let's see what I know for a fact that research exists out there, but what I want to demonstrate to you is that, like, yeah, based on the results, there are several recent papers exploring the use of large language models for grading and evaluating outputs, including their own. So they're already able to grade themselves, which means that you can automatically use them to at least grade the output sample. So then what we need to do is we need to reformat this. So actually, let me see if Claude can reformat this. Because if Claude can reformat this, if it can grade it and reformat it in 2 steps, that would be great. Okay, excellent. We need to clean up this data sample into JSON format. There needs to ultimately be only 2 fields, or I guess two data points. So it'll each point will have 2 elements. I can't remember how the JSON-L format is, but basically it'd be something like what was it? It'd be like no, hang on. I gotta pause this. It's been so long since I fine-tuned a model. Give me a second. Okay, goodness gracious me, I forgot. It's prompt response is the JSON-L format. Okay, so let's come back over here. Ultimately only be 2, it's not 2 data points, it's 2 elements. Prompt and response. Okay, so prompt will be user's actual query, not the preamble stuff. And then the response will be just Claude's, let's see, just the reasoning and solution with the other conversational bits removed. And now so let's see. So basically, you'll need to reformat the reasoning from the sample so that the user didn't need to give encouragement. Does that make sense? You'll need to, and by the way, like this is manual. This is a manual process, but what I'm walking you through right now is how I have tested this kind of stuff for years, which is you do it a few times manually with the LLM, either on a bench, on a workbench. So like the console here. So originally all you'd have is a web console here. We didn't have ChatGPT back in the day. Now I've got a chatbot, so I can just work with it to see how the LLM behaves. So then once you can generalize how the LLM behaves, then you can automate the process. So what I'm showing you is I got to test how this will actually work, and then I can automate the process. Because once you can automate it once, you can automate it a million times. And if you can have the LLM synthesize or clean up and annotate a million samples, you can do anything. That's automation engineer. This is my home base. Okay, so anyways, now that you've got some context as to what I'm doing and why, let's get back to the task at hand. So basically, you'll need to reformat the reasoning from the sample so that the user didn't need to give encouragement. Does that make sense? You'll need to basically swap out the user so that the chatbot was encouraging itself and redirecting or correcting its own reasoning instead of the user. Otherwise, it's okay that faulty logic was used at first because that's part of the process of reasoning. All right, so the reason that I'm okay with it keeping some of the faulty logic is because when you're fine-tuning a model, you need examples of it working correctly, as well as examples of it catching its own mistakes. So basically, each cycle where it messes up, it needs to stop and reflect and say something like, "Oh wait, no, that's not correct. This is imperative for training data sample quality." All right. Does all that make sense? Yes, that makes perfect sense. All right. So now it's going to generate an artifact, which, by the way, this actually looks like it'll work pretty well. Now it's correcting itself. All right, so what I'm going to do is I'm going to copy this to clipboard, and I'm going to come over here and see how this stacks up. Let me approach this step by step. So what I'm going to do is use my big human brain running at about an exaflop or so. Although what I'll say is that every time we build a new supercomputer, the estimated power of the human brain goes up by several orders of magnitude. So if I say that I have an exascale computer in my head, it's entirely likely that that's off by several orders of magnitude. And don't say that I'm going the wrong direction. I'm smart. Okay. Anyways, I don't have a petaflop in my head. I have more than that, at least most days. All right. So 10-word sentence, creating a structure, 10 letters. So it has walked through the problem. I'm still making mistakes. Let me focus more carefully on word length. So here we go. This is good. So verifying again, attempt 3, A to the 4. So this sentence meets all the criteria. However, I feel I can improve the coherence. Well, okay, so here's some really good self-talk. So this is what you would call reflection. So we're basically combining chain of thought reasoning with reflection and creating a single data point like what OpenAI shared over here. So you see, like, this process is relatively straightforward. Now, we're going to need to do a lot more than just this. Hang on. Where did I lost my, there we go. Wait, no. Good grief. Okay. Final attempt. I am the most adept. I can improve the coherence while maintaining word length. Let's see. This sentence meets all the criteria. So I don't know that this is right. Because if we come back over here, therefore the correct solution, you're almost coherent. Yeah, so it's a little bit, it's actually significantly shorter. So let's see how many characters this is. I understand the challenge. So that was 8,500 characters, which 8,500 characters, it's like what? I think it's about 3 or 4 characters per token on average. So that's like 2,000 tokens, 3,000 tokens, which is just, that's right about what you'd expect. But let's see how long this actual sample is. This actual sample is less than half of that. Okay. So that's not good. But that's okay, because that was literally the first attempt. All right. This is good, but the response you gave was less than half the length of the original reasoning. I'm afraid you cut out too much of the original reasoning. Please do it again and keep all of the original reasoning. The primary thing we need to change is just the user's encouragement so that it looks like the chatbot did the whole reasoning in one shot. Makes sense? So what I'm doing here is I'm refining my prompting technique. All right, so it's going to go again. And so basically what I did, so while it's processing, I'll tell you the prompt theory, the philosophy here. So the first time I said, like, all right, this is what we need. So I gave it the format. I said, this is the output that I need from you to clean up the data. And it's going to generate the data sample for me. However, I did not describe clearly enough what I wanted to retain. So what I needed to retain, I needed to specify retain literally all of the reasoning. This looks like it's probably just as short. I feel like it's missing something here. It's good that it's identifying that it's still making mistakes. But this feels, unless I'm doing something wrong. So 7,000 characters versus 30. Okay, so I think I just skimmed over it too quickly. So 7,000 characters, that's fine. Also, I know this video is getting a little bit long. We're at 25 minutes, so your attention is probably waning, and this was more than enough to get started so that you understand the theory of what we're doing and how I'm planning on approaching this synthetic data set project. And so because Claude has the ability to use code and use math to verify itself, we can then use that to actually, verify the samples. So basically the steps are that we covered today is we're going to need a whole bunch of questions, which then I was planning on synthesizing the questions today, but first I needed to basically prove out the approach. So we give it a question, we clean up the data, or we give it a question. We will need a user proxy. So basically, going back to the original conversation. Excuse me. So going back to systematic problem solving. So we're basically going to need, as we synthesize the data, here's what we're going to need. Long story short, we're going to need a whole bunch of questions like this. So we're going to need a bunch of questions that provide reasoning. Now, it would be impractical to have, a handful of PhDs write tens of thousands of questions. So we're going to need to find a way to synthesize the questions. Then we're going to need to find a way to synthesize these conversations. Then we're going to need to find a way to synthesize or to check the validity of the solution. And then, as I just demonstrated, we can clean up the data. So that's basically 4 steps. So step 1 is synthesize a boatload of good questions. Step 2 is synthesize a bunch of conversations, solutions to those questions. Step 3 is verify the integrity and quality of the solution. And then 4 is clean up the data for a fine-tune run. So that is, in a nutshell, what we're doing. We're breaking it down into 4 basic steps, which I've got outlined over here. So I'll probably add a notes section to the discussions here. So if you want to participate, you can. I do have a private team already, so please don't submit pull requests. But you're welcome to jump into the conversation. So I'll probably add this into the research section or something along those lines. But yeah, so thanks for watching. This project is going to take a little while, and but we'll see if we can get remotely close to state of the art in terms of reasoning. Certainly, we should be able to beat the underlying models that we train it on. But I mean, I didn't personally, having been in the research space for a while, I didn't see anything that OpenAI did that was like magical. Like you build a base model and then you fine tune it. A lot of people are confused about reinforcement learning. This is how you do reinforcement learning. You get more and more samples, and then you weed out the samples that are good versus the samples that are bad. That is reinforcement learning. All right, anyways, I'm rambling now. Thanks for watching. Bye.